Here we are with an IEC 61004-16 test setup using all this EMC partner equipment. We have multiple different coupling networks. This one is for doing standard AC line equipment. This can be used for telecom line equipment. And then we have another coupler here for inducing the DC disturbance. So with our IMU MGS generator, we are going to be running waveforms from DC to 150 kilohertz for both the short duration test at the higher voltage levels, as well as the frequency sweep from 15 hertz to 150 kilohertz. And we'll look at our test setup here. We have our decoupling network here. On this side, we're basically connected to a power source or the wall AC line voltage there to power a device. And then from here, we're connecting to our coupling network right here, which then goes to our DUT, which we're using this cool monitor. The signal then that comes from the generator goes in right here, and we also have a differential probe so we can monitor our waveforms on the oscilloscope. That is currently coming through the C-short extension, which is essentially an amplifier that gets powered by the PS3, and this takes the signal from the generator, amplifies it to the 300 volt level, and then injects it onto the device through this guy. So let's go take a look at these settings here. So for the C-short test, you can configure your output up to 330 volts. We'll do 300 volts. And you can do positive, negative DC, as well as the 16.7, 50, and 60 hertz for the short duration tests. And it sees our power supply that's connected. And then you can set your test time, the duration of the pulse, how often it repeats, and whether you're triggering it automatically or manually. And so at this point, we can hit run. Instant replay of the DC 300 volt waveform looks like that. And we're currently injecting that through our coupling network onto our device. All right, now for the common mode sweep from 15 hertz to 150 kilohertz, the test setup has slightly changed. We are still using the decoupling network, power from here, going to our coupler, and this is now our AC line coupler, and you can see the connections are sort of interesting here. You have your power going in on the output side of the coupling network that goes to the EUT, and then we have our cable to our EUT over here, and then the signal from the generator with the differential probe on top of the oscilloscope is going in on this side, which now connects directly to the front of the generator. So these two units are not being used for the common mode sweep at the lower voltage ranges. So let's go into the settings here, and we can see 15 hertz to 150 kilohertz. There's our nice diagram for the amplitudes as specified by the standard. You could do a fixed point as well if you'd like, but we're going to stick to the frequency sweep. And you can do the fixed point, but let's pick our level. We'll stay at 30 volts for this demonstration, and then you can pick how fast you want it to sweep across that frequency range. So our settings look good. We'll click run. We'll see what happens on the oscilloscope here. And we can see we have our frequency measuring, and the amplitude is lowering as we go up in frequency, and then at a certain point our amplitude will start to increase as specified by the standard. Alright, so we're at 10 volts now at 5 kilohertz and growing. Let's see, okay. Going the wrong direction here. All right, so we are at a 30 volt sine wave at about 100 kilohertz and 150 kilohertz. All right, so we're gonna look at how to do a report real fast, but during the test, we marked a failure at this point by tapping the button, and now we're going to look how we save the report to our USB, and you can just click the button, do that, and we'll take a look at what that looks like here in a second. Here's the example report showing the test that was ran, as well as observations made in yellow and failures in red. And to quickly review the connections on the back, we have our power connections to these two units, the IMU MGS and the PS3. And the PS3 is powering the IMU C-short extension down here through these 3 banana connections. And then we have this nice comms cable RS485 to RS232 right here that connects all 3 units together for comms reasons, and then we have our safety circuit as well. Thanks for watching our video on IEC 61000 4-16. Keep in mind, with this system, you can also do testing for 4-19. Give us a call anytime at ATEC. We have the knowledge, the equipment, the solution.